Hello everyone. Uh, Last class we have studied about the evaluation of integral over a curve, for a curve where the curve is a straight line. Now we are going to talk about a curve defined by equation which are curve. Not straight, but some may be straight, but which also include a curve which which is bent or something like that. So now we will try to evaluate this one. The curve that we have is for number 1, this one, y cube equal to x square, and the line joining 0, 0 to 1, 1, and the second one is closed curve formed by y squared equal to x and y equal to x. What I think is this one is a little bit easier, so I will do the first one. You may do this, you may try this this one, the evaluation over C, where C is this one. So I will do the first one. So let us try to find what is the curve y cube equal to x square and the line joining 1, 0, 0 and 1, 1 in the graph. So we have the y-axis here, the y-axis, sorry, a little bit, the x-axis here. So what we have to think is the line joining 0, 0 to 1, 1. Suppose we have 0, 0 here, 1 here, and also 1 here. So the point 1, 1 is the x-axis 1, the y-axis also 1. It will be around here. So the y cube equal to x square, y cube equal to x square passes through this 1, 1, because if you put 0, 0, 0, 0 is satisfied by this equation, and 1, 1 is satisfied by this equation. So we can surely know that y cube equal to x square passes through the 0, 0 and 1, 1. Now other than this 0, 0 and 1, 1, it does not first of all, let's also talk about this line joining 0, 0 and 1, 1. The straight line, by a line joining 0, 0 and 1, 1, we mean by a straight line. So 0, 0 and 1, 1. If we talk about this one, y cube equal to x square, it passes through 0, 0 and 1, 1. But these powers, from these powers we can know that it is bended. So we cannot in these papers it is very difficult to draw the exact curve. So what I used to do is that I see the power, and if the power is less on the x side, then it bends towards the x side. If the power of y is less, then it bends towards the y side. So we can say that this line y cube equal to x square, the bending, the power of x is lesser, so we can assume that it bends on the x-axis. So we have a closed path now. My path is 0, 0 to 1, 1 and 1, 1 to 0 in this path. So my we are traveling. My path will be traversed like this. Okay. So we can say that the curve consists of, the curve C consists of two paths, that is straight line from 0, 0 to 1, 1, and y cube equal to x square. Now in order to see the straight line, the equation of this one, in mathematics usually 0, 0, 1, 1, 2, 2 and all, the equation is known to us, y equal to x. The equation is y equal to x. But if in the previous videos I have talked about the equation, how to solve the equation of a straight line passing through 2 points. So we can use that one for path a straight line from 0, 0 to 1, 1. So y minus, this is 1, 1, y minus, if you don't know this how to get the equation, you can see the previous videos. So y minus y1 is 0 by x minus x1 is 0, and here y2 is 1, y1 is 0, and my x2 is 1, my x1 is 0. So this gives me y equal to x. So my y equal to x is the straight line from 0, 0 to 1, 1. So for this one I can put x equal to t, then it follows that y equal to t also. So dx is equal to dt, and dy is also equal to dt. So you can put everything here as this in terms of t. So let's say this path, for path, let's say this one is c1, that is a straight line. So we can talk about integration over c1, x plus y square dx plus x square minus y dy. This will be equal to integration over, if I put x as t, we know that x varies from here to here in the straight line, and the x varies from 0 to 1. So I can put 0 to 1 because x is equal to t. So this becomes t plus t square. Instead of dx I can put dt plus t square minus y. Here again we can put dt. So this will give me integration over c1. This is still equal to, let's see this one. Sorry, instead of y I can also put t. I have to put t, not I can put, I have to put t. Okay, so for this I can write 0 to 1 t plus t square plus t square minus t dt. So this is 0 to 1 2t square dt. So this is 2 by 3 t cube, or 2 to t cube by 3, same. So I get 2 by 3. Okay, next what I can do is I have to write for path C2, let's say C2, that is y cube equal to x square. Then I can put here also I can put x is equal to t, that is put x equal to t. So in order to know the figure of that line, let's draw again. 1 1, this is 1 1, so that is the straight line, the c1, and this is y cube equal to x square. So my path is like this. So we put x is equal to t. Then what about y? Y cube equal to t square, which implies what? Y equal to t 2 by 3. Okay, then dy is going to be equal to 2 by 3 t to the power 2 by 3 minus 1 dt. That is dy equal to 2 by 3 t to the power minus, here 3 ones are 3, it is minus, so I get 2 minus 3 is minus 1 by 3 dt. So here also, as x varies from, see, the x varies from, this is 0 0, this is 1 1. We put x equal to t. So as x in this part, the x varies from 1 to 0. So the t must also varies from 1 to 0. So integration over c1, as x varies from 1 to 0, t varies from 1 to 0. So now I can write integration over c2, I forgot that one, x, let's put that one, x plus y square dx plus x square minus y dy. This will be equal to integration over 1 to 0. Instead of x I can put t, and instead of y I can put y square. Since the y is equal to t to the power 2 by 3, the y square will be t to the power 4 by 3. And instead of dx, I can put here, I can write dx is equal to dt. So dt plus, I have this x square, I can put t square minus, what about y? Y is equal to t to the power 2 by 3 dt. Then, we cannot put dt. Instead of dy, I have to put 2 by 3, 2 by 3 t to the power minus 1 by 3 dt. Okay, so this will be 1 to 0 t plus t to the power 4 by 3 plus 2 by 3 t to the power 2. If I multiply this one, I can just add the power, minus 2 by 3 t to the power 2 by 3 minus 1 by 3 dt. So this is 1 to 0 t plus t to the power 4 by 3 plus 2 by 3 t to the power 3 to the 6 minus 1 is 5 by 3 minus 2 by 3 t to the power, since the denominator is the same, 2 minus 1 is 1 by 3 dt. So this will be equal to I can integrate this one now. T to the power t square by 2 plus t to the power 4 by 3 plus 1 is if I 3 ones are 3 plus 4, 7 by 3 by 7 by 3 plus 2 by 3 into t to the power 5 by 3 plus 1, 5 by 3, 5, 6, 7, 8, 8 by 3 by 8 by 3 minus 2 by 3 t to the power 1 by 3, 3 ones are 3 plus 1 is 4, 4 by 3 by 4 by 3 evaluated at 1 to 0. So here what I can do is if I put all zeros then I get 0 minus here I will get 1 by 2 plus here I will get 3 by 7. Here I will get this one and this one will be this one and this one can get cancelled. I have 2 by 8. 2 by 8 will be 1 by 4. Here I will get 3 and 3 will get cancelled. 2 and 4 will be 1 by 2 minus 1 by 2. So this is equal to minus this and this can get cancelled. So let's write here. 7 4s are 28. 28. So I will get for 12 plus we have to know that there is still minus here. 12 plus 7. So this will be equal to minus 12 plus 7 is 19 by 28. So what we can do now is we can add those two, the integration over integration c x plus y square dx plus x square minus y dy. This will be equal to integration over c1 plus integration over c2. So this will be equal to the first one which I got is 2 by 3 minus 19 by 28. So I think we will be able to solve this one. 2 by 3 minus 19 by 28. And going back to the result, this result will give you the answer. So going back to the second problem, a closed curve formed by y squared equal to x and y equal to x. We now know that y equal to x is the straight line from here, straight line from 0 0 to 1 1, and y squared equal to x, it will be bent again in the x side. So I hope you can do that, and I'll leave you also with one problem. Here the problem that I will give you, it will be the same with this part, the first one, but the integrand will be different. So here is this one. So you can evaluate x square y dx plus xy square dy, where c is the part, this one. Thank you.